Hello everyone. In this video, I would like to talk about how to apply the Hess law to find the enthalpy change which cannot be measured directly. In the Hess law, the change in enthalpy accompanying a chemical reaction is independent of the pathway between the initial and final states. For example, if we convert A to B and B can convert into C, there are two steps in this synthetic pathway, and they have their own enthalpy change in each step. However, A can also convert into C directly, and it has its own enthalpy change. According to Hess law, the enthalpy change is independent on the pathway, but only depending on the initial and final states, so that we can conclude that delta H3 for converting A to C is equal to delta H1 plus delta H2. And I will use another example in your notes to illustrate the concept of Hess law. Ammonia gas and hydrogen chloride gas can be converted into ammonium chloride solution by forming the ammonium chloride and then dissolve the ammonium chloride solid into water, and the overall enthalpy change is about minus 159.8 kJ per mole. On the other hand, we may dissolve the ammonia gas and hydrogen chloride gas into the aqueous solution first and followed by the neutralization reaction. And the sum of the enthalpy change for the second synthetic route is more or less the same for the enthalpy change in the first step. From this example, we can realize that the enthalpy change is really independent of the synthetic routes. Here's an example in the notes. We need to calculate the enthalpy change of formation of methane by using the enthalpy of combustion provided in the question here. And this is the chemical equation for the heat of formation of the methane. As we know, graphite and hydrogen, they cannot undergo a reaction to form the methane in the standard condition. But carbon can combust to form the carbon dioxide. Hydrogen, it can combust to form water, and also the methane can combust into carbon dioxide and water, so that we can build up an energy cycle. And in this energy cycle, we can find out the relationship between the heat of formation that we are going to find and also the heat of combustion that provided by the question here. Also, we can find that there are two synthetic routes. We start from carbon to form methane, and then the methane combusts to form carbon dioxide, or the carbon and hydrogen, they undergo combustion to form carbon dioxide and water. Therefore, the enthalpy change in the synthetic route 1 is equal to the enthalpy change in the synthetic route 2. And delta H4 is the enthalpy change that we need to find. So we put the data provided from the question, and we can find out the answer, which is the heat of formation of methane. In the energy cycle, you need to clearly show the direction of the reaction. And also you have to write down the state symbol for all the substances here at the standard states. On this page of your notes, you can see a very typical question in the public exam. You need to define some of the enthalpy change, and you also need to write the equation for the formation of the substance from each element. In this case, ethanol C2H5OH is a liquid at room temperature, and of course it is formed from carbon in form of graphite, and hydrogen is the gas, and also oxygen gas. If we need to build an energy cycle to find out the heat of formation of the ethanol, then I would use the equation that we need to find on top of the cycle. And then they will undergo combustion to form carbon dioxide and water. In order to balance the formula, we need to add 3 oxygen gas so that here we should put 3.5 oxygen. And of course, remember, we need to write down the states for all the compounds or elements here. And here, this is the delta HF that we need to find. This is the delta HC, heat of combustion for the ethanol. And also, we have combust 2 carbon the graphite, and also 3 hydrogen has been combusted. Then this is the energy cycle. In this energy cycle, we can see the elements here. They are the starting materials. We can convert the carbon, hydrogen, and oxygen into ethanol first, and then combust into carbon dioxide and water. Or they can directly combust to form carbon dioxide and water. And now we can find out the relationship between the formula from the cycle. And here, the delta HF plus the delta HC of ethanol is equal to the red arrow, the delta HC of graphite, and delta HC of H2. So the delta HF is equal to, and the answer can be found. They can, for example 2 here, we need to convert the ethyne gas into the benzene. The other data provided are the molar energy of formation of this compound. Therefore, we can build up an enthalpy cycle like this. Because both of the ethine and benzene, they are formed from carbon and hydrogen. From the cycle, we can also see that the carbon and hydrogen can be converted into ethine and then further converted into benzene, or the carbon and hydrogen can be converted into the benzene directly. In our calculation, we can find out this relationship. Then we can now find out the answer. For part B, if you want to find out the molar energy for the combustion of the ethine, then they will combust to form the carbon dioxide and water, and of course we need some gas, some oxygen gas. And also, both of them, they are formed from the carbon and hydrogen. And now we can build up a cycle like this. We may convert the carbon and hydrogen into the ethine gas first, and then convert into the carbon dioxide. And also, the carbon and hydrogen can also be converted into the carbon dioxide and water directly. And finally, the answer can be found. For question number 3, we need to find the heat of combustion for the octane, and we can build the energy cycle like this. The octane can be combusted into carbon dioxide and water, and also the octane is formed from the carbon and hydrogen. Carbon dioxide and water, they are also formed from carbon, hydrogen, and water. From this cycle, we can find out their relationship. Carbon and hydrogen, they convert into the octane and then combust to give the carbon dioxide. And also, the carbon, hydrogen, and oxygen, they can also directly convert into the carbon dioxide and water on the right-hand side. And then we can find out the answer, which is 5,476 kJ per mole. In these few examples, we can find out the unknown value by using the energy cycle. On another page, I will use another method to find out the answer. On this page, I will find out the answer by using a cross-out method. In this question, we will mix the silver nitrate solution with the dilute hydrochloric acid to give the silver chloride solid and nitric acid. But actually, the silver ion reacts with the chloride ion to give the silver chloride solid. Hydrogen ion and nitrate ion are spectator ions. So here I will find relevant chemicals and equation to build an equation like this. First of all, silver chloride will be formed as a product. And then I will use the fourth equation here. Silver chloride will be formed as a solid from the silver metal and chlorine gas. And now I will choose the silver ion for the left-hand side and cross out the silver metal from the second equation here. So I will put the first equation here but the equation here is the reverse process for the first equation. So the energy change should be a negative value. And then I will copy the third equation to cross out the chlorine gas on the left-hand side here. And after we have crossed out the electrons and the unwanted materials, the materials left are the equation that we want. Then we add up all the energy change here, and we may obtain the answer. And this is the answer.